Hello, everyone. This is me, Rami Salem, a senior consultant from IQRM. Today, I'm going to provide you with a quick presentation about what is Monte Carlo simulation is all about. So, the history of Monte Carlo simulation it started from the World War II war, and it was meant to be invented to support decision making in the so that every hit may have the best effectiveness. It was invented by two mathematicians, John von Neumann and Stan Wool. So the name it came from the well-known casino town Monte Carlo, which is like it's a sense and because there is an element of chances, and there is it's mainly focused on Monte Carlo simulation as a method on like counting different chances of different scenarios. And so the Monte Carlo simulation was called Monte Carlo since it's similar to gambling and similar to the probabilities and chances of every gamble. So how it works. So it simply starts with as the step that you have to estimate the range of every value of each risk. Estimate the range, for example, saying this risk has an estimated impact from 10 days to 30 days, and also providing in the probability of this impact. Like, for example, how much this impact will have on what's the probability of this impact to actually occur. And next thing we have to set is to define something called a probability distribution. A probability distribution, you can think about it like an algorithm that teaches the Monte Carlo simulation engine that how we're going to deal with this estimated range of values. So it's a simple way just to explain to the Monte Carlo simulation how it can be done, how we're going to deal with this data inputted. Then we have correlation. Correlation is all about building relationship between the different risks. For example, if there is if the temperature is down, there you're going to, for example, most likely you're going to like pay more for heaters and so on, more electricity bill. So, or for example, if we have more steel structure loads, then we're going to have more foundations. So it is just some kind of building a relationship between different factors. And then we have, after we finish this, before all of these steps, we have to really know our inputs and assumptions, from where we're building it, how we're going to be building it, and so on. So it's three simple steps. First, estimate the range of values for every input you have. Then probability, set up an appropriate probability distribution, and then build up correlation. Correlation may exist and may not exist. Then next step is to provide or the range of probability distributions and correlation in all of them all together. Run a Monte Carlo simulation, which, for example, 5,000 iterations, and then do a probability that it shows you a probability, something called probability density chart. And 5,000 iteration, as if you, for example, if it's for a project, if as if you're doing the same project 5,000 times, and every time it has a new assumption. So it provides you this histogram. This histogram it shows you what the possibility of every, for example, here for doing for a profit of a company, that what are the different possibility ranges for the profit of this company. And then we look at, for say, okay, we want to ask what's the probability that we have our profit between 50,000 till 159,000. So this will be part of it. So we can understand, okay, we have 90% probability to achieve this within this range. And then we have something called tornado chart. Tornado chart is a chart that shows you what are the key factors that is affecting your model and affecting the output of the Monte Carlo simulation. So it gives you good guidance where we should be focusing on next. Then we have the confidence level interval that, as I told you, that we need to set maybe an interval that we are studying or we are interested in. So And then we can use it for contingency planning. For example, if I said this is a cost, not a profit, and I want to say I have, for example, an 80% confidence my budget will be within $145,000, and my current estimate is 130. So if I want to be 80% sure that I'm not going to have a budget overrun, I would need $15,000, which is the difference between the 145 and 130, to be confident by 80% that we're not going to have a budget overrun. So we explain more of this in something called the QRM diploma and certificate. Is we quantify risks for integration in decision making, not just for the sake of quantification. And this QRM diploma consists of three modules, which is first the foundation for quantitative risk assessment, which is we learn how to uh, what are the fundamentals of risk management, how to do Monte Carlo simulation, and also the probability distribution being used. Next, we have the second module, which is building the risk model itself. So here we learn how the basics exactly, what is Monte Carlo simulation is, how to select the probability distribution. In second module, we learn more about building models. So we build a risk register model, we build a schedule risk analysis model, and a cost risk analysis model. So, and basically here, lastly, so since we have known how to build things, how to set probability distributions, we have known how to build the models. We need to compare between decisions. We need to use this information to support decision-making process, either in projects or enterprise. So we learn something called compare between decisions. We learn something about stochastic dominance as a statistical method, and another statistical method called utility theory. That both of them basically helps you with decision making. So all in all, IQRM provides this certificate, and after this, you get an exam and a certificate that is accredited by an Institute of Qualified Risk Managers to help you to actually to practice the methodologies of quantitative risk management. So if you need to know more about it, you can click down below you can see down below the courses and you can know about it. And I hope it was a quick introduction to Monte Carlo simulation. I hope you liked it. This is me, Rami Salim, and see you next time.